Hello dear AP Chem students, welcome back to our second video on common ions figuring out the solubility given the KSP of a solution in which you already have something else dissolved, in which you have a common ion dissolved. So this is your question: what is the solubility of calcium fluoride in a 2 molar NaF solution with the given KSP of 1.54 times 10 to the minus 3. The first step again is to write the dissociation reaction. So we did this right here. Calcium fluoride dissociates into the cation of calcium 2 plus and the anion of 2Fe minus. Notice that there are coefficients here because there's 2 fluorine atoms for one calcium atom. So we have calcium 2 plus 2 Fe. So this is solid, this is aqueous. Next step is to write the ice table. So we drew a line through calcium fluoride because this is a solid and solids do not count in the ice table. So we have 0 molars of calcium 2 plus in the solution at the beginning of the reaction, so we put a 0 here, and we're going to be making plus X. We do not know how much it is, so we put plus X. And then we put a 2 here. Why did we put a 2? Because it's given that in the solution there's already 2 molar sodium fluoride solution. There's already 2 molar fluorine atoms in here. So we put a 2 here because it's given that we're putting calcium fluoride in a 2 molar sodium fluoride solution. There's 2 molars of fluorine, hence we put a 2 here. So 2 plus 2x. The reason we're putting a 2x here is because the coefficient of the fluorine is a 2. This is a key note to make because when we're putting plus x, we always want to correspond this with the coefficient. So in this case, the coefficient is 1, so we're adding plus 1x. In this case, the coefficient is a 2, hence we're adding plus 2x. It's very important that you balance the equation to make sure that your coefficients are correct, or else your plus x and your plus 2x would be incorrect. Now you just add straight down. 0 plus x is x, and 2 plus 2x is 2 plus 2x. So next step is to write the KSP. KSP equals to the concentration of fluorine squared times the concentration of Ca2 plus. Where did I get the squared? Basically, the coefficient that you have, you raise that to the power of the concentration of that anion or the cation, depending on where the coefficient is. In this case, we have a coefficient of 2 with the fluorine anion. Hence, we're going to put a hence we're going to raise the concentration of fluorine to the power of 2. So Fe to the power of 2 times the concentration of calcium 2 plus. It's given that the KSP is 1.54 times 10 to the minus 3, that's given up here, equals to, we figured out the concentration of Fe, meaning fluorine, is 2 plus 2x to the power of 2, I'm just basically substituting, times x. So when you figure this out, solve for x using a graphing calculator, which is the best thing I can do. So what I do is basically, I go here, and I click y equals, and I basically graph the function. So I have 2 plus 2x to the power of 2, make sure you close the parentheses, times x, and basically I subtract this over to the right in order to set this whole equation equal to 0. So if I just bring this over, basically if I subtract 1.54 times 10 to the minus 3, and just press enter, and make sure I'm in the zoom, oh my god, where am I going? Zoom standard, just graph the function, and in this case, just calculate the 0. So that's your lower limit, that's your height. If you know a better way to solve this, solve it in your way. Anyways, I got that basically x equals to 3.85 times 10 to the minus 4. This is our solubility. Basically, this means that we are able to dissolve 3.85 times 10 to the minus 4 molar. This is a concentration of calcium fluoride that we can dissolve in a solution where there's already 2 molar fluorine present. Thank you.